degree of the homogeneous function as well as applying the Euler's theorem. So yesterday we have started with homogeneous function. We have defined what do you mean by homogeneous function. Yes, can anybody revise it? Is Sagar Mahure present? Roll number 53, I suppose. Is he present? Okay. Roll number Abhishek Nikam. Are you there?
Present, ma'am.
Yes. Yesterday we have done homogeneous function definition. Can you tell me what is homogeneous function?
No.
Aditya?
Present, ma'am.
Aditya Dhai. I'm not asking Aditya Dhai. I'm asking Aditya Bile. Roll number 9.
Yes, ma'am.
Yeah. Yesterday we did homogeneous function. What is the homogeneous function?
Ma'am, please can you repeat it?
What is the definition of homogeneous function? A function which can be written in the polynomial form a naught x raised to n plus a1 x raised to n minus 1 y plus dot 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 an x raised to 0 y raised to n. This was called as homogeneous function. Why it was called homogeneous function?
Because the powers are same.
Yes.
That is
and
n.
how could we? Yes, very good. And how could we rewrite it?
Ma'am, we can take x raised to n
Yeah, common.
in common into bracket. In bracket a. Okay, phi is a function. We can take it.
That is also possible. Find the function of
A. Why? So
everywhere we can take x raised to n common, then whatever remains is a function of y by x. So if you are able to rewrite f of xy as x raised to n into phi of y by x, that is actually what I was trying to say. It was a naught plus a1 y by x because I took n x terms common, but there are n minus 1 terms, so I have to divide by x plus a2, it will be y square upon x the whole square plus dot 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 an will be y by x raised to n. So entirely whatever is there in the bracket is a function of y by x. So if I am able to write given function z which is in xy in the form x raised to n phi of y by x, then it is called as homogeneous function of degree n. Homogeneous function of degree n. Is this okay? And on the same lines, there is nothing special about x. We can also write powers of y, that is y raised to n. It should be some function of x by y.
X by y.
Yes, good. So it should be a function of x by y. Then we also say that it is homogeneous of degree n. This is the definition of homogeneous function. So it will come from 1 mark. A function f of xy is said to be homogeneous if it can be written as x to the power 0 phi of y by x to the power n phi of y by x to the power n phi of x by y, and none of this. So your correct option will be x raised to n if you are taking common, it should be y by x. Y raised to n you are taking common, then it should be x by y. So this is the basic definition. Is this okay? All the terms should be of same degree, but we can rewrite it in this form. Is that clear to everyone? What is the meaning of homogeneous function? Now we'll see the examples on this. Okay, I'll take an example first, and then I'll ask you to find out the degrees of those particular homogeneous functions. So the first question that I want to ask you is, or we'll solve is, suppose u is equal to f of x comma y, which is x square plus y square divided by x plus y. This is a function x square plus y square upon x plus y. So this is of the type function by function. What is the degree of the numerator?
2.
So I can take x square common. If I take x square common, I will get like this. Isn't it? X square into 1 plus y by x the whole square divided by, what's the degree of denominator? 1. So I can take x common. It will be 1 plus y by x. So in all what it is x to the power 2 minus 1. That is 1. X to the power 2 minus 1, which is 1, into some function of y by x. Is this okay? This entire thing which is there is a function of y by x. So what is the power of x? The power of x is 1. So what is u? U is homogeneous of degree of degree 1. Is this clear to everyone? Very simple.
Yes, ma'am.
Okay, degree
Yes.
of this particular function, it is homogeneous and it is having degree 1 because it is function by function. Degree of the numerator is same, degree of the denominator is same, and since I am using this property of taking x to the power n common, I am getting totally x to the power 1 into phi of y by x, hence u is homogeneous of degree 1. Okay.
Yes.
Yes.
Now you solve the question that I am going to give you next. Let me give another example which is also not so difficult. So take u is equal to say x cube, y cube, z cube divided by x cube plus y cube plus z cube. Find the whether it is homogeneous. Whether it is homogeneous, that you find first, and if it is homogeneous, then find the degree.
Ma'am, what is A naught?
A naught is a constant. It's a polynomial. A naught is a constant. So constant can be written as y by x raised to 0.
Okay.
Yesterday I told you this. A naught can be written as A naught into y by x raised to 0. Yes. Now you try to do this. U is equal to x cube, y cube, z cube upon x cube plus y cube plus z cube. Not more than 1 second you should repeat. The answer is 6. Degree of this function is 6. Yes, how you got it? What's the degree of the numerator?
9.
9, because it is product. All these terms are multiplied. So the power will be added. 3 plus 3 plus 3. It is not addition. So degree of the numerator is 9. So I'll take x raised to 9 common. So it is y by x raised to 3 into z by x raised to 3. Divided by, I'll take x cube common. 1 plus y by x cube plus z by x cube. And therefore the degree is, this is nothing but x raised to 6. X raised to 6 into some function of y by x comma z by x. It is, as I did here, x raised to 6 into some function of y by x comma z by x. I hope this is clear. There were only 2 variables. In this question, there were only 2 variables, so I got only y by x. Now there are 3 variables. So y by x comma z by x should be your function depending on. Phi should be depending on y by x and z by x. That's why your answer will be u. U is equal to x raised to 6 phi of y by x comma z by x. Okay. This is very important topic and many students are not there today. So they are going to miss out.
पॉवर 9 का घेतली न्यूमरेटरला कसं
बघ ना प्रॉडक्ट मध्ये किती टर्म्स आहेत x y z प्रॉडक्ट मध्ये आहेत कुठल्याही एक्सप्रेशनची डिग्री आपण काढतो तेव्हा कशी डिग्री काढतो जर प्रॉडक्ट असेल तर त्यांची पॉवर ऍड करतो ना
हो
तर इथे 3 x ची पॉवर आहे y ची पण पॉवर 3 आहे z ची पण पॉवर 3 आहे सो इट इज 3 plus 3 plus 3 9 is the degree of the numerator.
ठीक है
That's why we took x raised to 9 common.
Ma'am,
Okay.
how to write the final answer? We are comparing it with the equation gap, first wala.
While writing homogeneous function, you have to just write it as x to the power n. If there are 2 variables, then you have to write only one variable by another. If there are 3 variables, then you have to write second by first and third by first. So how many variables are there? X, y, and z. So you should be able to write x if you're taking common. Then you should be able to write x phi of y by x comma z by x. Then I said that it is homogeneous of degree n. What is that n over here in this example? 6. So it is homogeneous function of degree 6.
Okay,
Clear?
ma'am. Yes, ma'am.
Ma'am,
Yeah.
it is compulsory to take x raised to 3 common, or we can take y raised to 3 also common.
You can take y raised to 3, but numerator also you have to take y raised to 9 then. Because you want to cancel, na? In the numerator you will take x and denominator you will take y, then you won't be able to tell the degree, write this equation in particular form, that is x raised to n. You're going to write x raised to n and y raised to something, minus something. But that won't give you the degree. What is the expected form? X to the power n into the function of y by x if there are only 2 variables. If there are more than 2 variables, then y by x comma z by x comma all those things.
Okay, ma'am. So we can take x, y, z, any of them common.
Yes. You can take z raised to 9, you can take y raised to 9. If you are taking y raised to 9 in the numerator, you have to take y raised to 3 in the denominator. If you are taking z raised to 9 in the numerator, take z raised to 3 in the denominator. Because you should be able to write it as Z to the power, Y to the power, or X to the power. Don't mix the variables. Okay? Fine. Yeah. So next example you can take down now. U is equal to x square plus y square divided by 2xy. What is the degree of this function? Is this homogeneous? And what is the degree of this function?
Degree 1.
0. 0.
Everyone, please see that the answer is 0.
Yes.
Numerator degree is 2, so I'll take y square common maybe here. So it is x by y the whole square plus 1 divided by, I'll take y square again common, because again see here, those who are asking me why to 9. What's the power of x? 1. What's the power of y? 1. So 1 plus 1 2. So I have to take y square common so that I get 2x by y. And entirely this is y raised to 2 minus 2 into some function of x by y. That is y raised to 0 into some function of x by y. And therefore this is homogeneous of degree 0. Okay? Clear? Everyone?
Yes, ma'am. Yes.
Any doubt to anyone, please ask. Okay, because this is actually these examples will be there in ample for everyone. You may get three examples of homogeneous only in your final examination of MCQ. Because 1 mark question, if they are expecting, then such type of questions will be asked. So you should know how to find the degree. And when it is an MCQ exam, there is no need to show actually all these things. Take the degree of numerator, take the degree of denominator, subtract them, that's your degree. Is it okay?
Yes, ma'am.
Now you take one more example, fourth example, and you tell me the answer. U is equal to sine of x square minus y square upon x plus y. Let me first write down this one. 2xy first. U is equal to.
Ma'am,
it is not visible.
can't see.
It's not visible.
Okay, that part is not visible. Let me do it on the other side then. Try to find out this equation. U is equal to sine of x square minus y square upon 2xy. Tell me what's the degree of this? Is this homogeneous? And if it is homogeneous, what's the degree?
0.
Is everybody getting the answer to be 0 again?
Yes, ma'am.
Yes, ma'am.
What do you do? What do you have to do about the sine term?
Ma'am, sine 0 is 0.
Sine inverse u.
Yeah, sine.
If you take sine inverse u, then u is not homogeneous. Sine inverse u will be homogeneous, isn't it?
Yes,
जब
ma'am.
साइन दूसरा रचना क्यों किया ये साइन अगर इस साइन लेकर जाएंगे तो साइन इनवर्स u हो जाएगा तो साइन इनवर्स u will become homogeneous. But in this specific case, since the degree is 0, numerator degree is also 0, denominator degree is also 0, then just see here. Generally you do this, na? 1 minus y by x the whole square divided by x square into 2y by x. So x square is getting cancelled. Now this is sine of some function of y by x. That means it is function of y by x only ultimately. Yes or no? ये y by x का function है, sin उस पर apply किया है तो वो भी y by x का ही function है. So this is entirely a function of y by x. Function of function which is on which is of y by x. So I can write here x raised to 0. Whether you write x raised to 0 here or x raised to 0 here, it is one and the same thing, na? Because what is x raised to 0? X raised to 0 is 1. Yes or no? Yeah.
Yes,
so that's why U is directly homogeneous of degree 0. Of degree 0. Clear? This is a special case. So the degree of the function inside sine is actually 0. That's why whether we write x raised to 0 after sine or before sine, it won't make any difference because it is function of y by x itself. Sine of y by x means function of y by x. So I can write x raised to 0 here. But if I have to write x raised to 1, then I cannot write it here unless and until I can take it common. So that example is next. Just see. U is equal to tan inverse of x cube plus y cube upon 2xy. Suppose this is the function. u is equal to tan inverse of x cube plus y cube upon 2xy. So is u homogeneous?
Yes, ma'am.
Is u homogeneous? I'm asking the question again. Please tell me.
No, ma'am.
No, ma'am.
No, ma'am.
If u was
No, ma'am.
homogeneous, I should have been writing x to the power something into this tan inverse as it is. Now look at the function here. This is tan inverse into x cube. I can take common 1 plus y by x the whole cube divided by x square. I can take common 2y by x. Okay. I can cancel out x cube and x square with 1x remaining. Can I take this x directly outside? This x, can I take it outside? No, tan inverse is there in middle. So I have to take tan inverse on other side. Then tan u is equal to x into some function of y by x. So who is homogeneous? Tan u is homogeneous and not u. So u can be called as function of homogeneous expression. U is function of homogeneous expression, that is called as f of u, which is tan of u. In this case, f of u is equal to tan of u is homogeneous. F of u is equal to tan of u is homogeneous of degree 1. Is that clear? Difference between the normal functions which are directly homogeneous and f of u is homogeneous. Is that clear to everyone?
Yes, sir.
Yes.
Okay, fine. So this example, what is the difference? If the degree of the inner term is 0, then directly you will be homogeneous. Please listen carefully. Yeah? The function which is inside tan inverse or sine of or log of any one of them, if the function which is inside is having degree 0, directly you will be homogeneous. But if the function which is inside is having non-zero degree, then the outside function which is there has to be taken on the left hand side, and then you get f of u, which is homogeneous of the degree of this internal expression. अंदर का जो एक्सप्रेशन है या फंक्शन है उसकी जो डिग्री है अगर वो नॉन जीरो रही तो हमें बाहर वाला फंक्शन लेफ्ट हैंड साइड लेकर जाना पड़ेगा एंड दैट फंक्शन विल बी होमोजेनियस ऑफ द डिग्री व्हिच इज ऑफ दिस इंटरनल एक्सप्रेशन. इज दिस ओके? Clear?
Yes, ma'am.
Yes.
Okay, so there are two types of homogeneous function. One is direct homogeneous function where the degree is directly available and we'll be taking it common and dividing, we'll get the degree of the expression. Outside, if there is any function, we have to check whether the internal function has degree 0 or non-zero. If it is 0, then the given expression u is homogeneous. If the internal degree is non-zero, take the function which is outside the bracket on left hand side, and then you'll get f of u, which will be homogeneous of degree, which is of the internal expression. Okay, clear? I'll give you one more last question now. You try to tell me the correct answer of that. Okay, u is equal to 1 upon x raised to 5 cos of x minus y upon x plus y. What is
Minus
this?
5.
Yes, very
Minus
good. Degree is minus 5 because internal function is having degree 0. So this will become some function of y by x. If I take x common, this is x raised to 5, it will go as x raised to minus 5 outside. First term, and this is x raised to 0 into some function of y by x by taking x common. So it is overall x raised to minus 5 into some function of y by x, and therefore u is homogeneous of degree minus 5. Clear? Clear?
Yes, ma'am.
Yes. Yeah. Is there any problem in the visibility of the board?
No, ma'am.
No,
No.
ma'am.
Okay, fine. Because some student was writing, Kavita was writing that board cannot be seen properly. What is happening? Is it reflecting or something like that?
No, ma'am.
Actually, not.
Clear, ma'am.
No, ma'am. It's okay. Fine.
Maybe network issue.
Okay.
The issue from our side.
Okay. Fine. Okay, so let's go to the actual topic now. This will be there definitely in your MCQ. But why we are studying this Euler? Why we are studying this homogeneous function? Because there is something called as Euler's theorem. Euler actually gave the partial derivative equation for homogeneous function. If your given expression u is a homogeneous function, then a fixed type of partial derivative can be evaluated directly with the help of one formula, and that formula is given by Euler's theorem. So let me state that theorem, and I will prove one of its form. There are around 4 Euler theorem of first order and second order, depending on whether u is homogeneous or f of u is homogeneous. And then we can see that till now we have actually found the partial derivatives and got the answer, final answer. But if you know that the function is homogeneous, then directly you will be getting the expression of that partial derivative. So let me write down the statement first. We'll understand it and then we'll see how do we apply. Okay. So write down the statement. If u is a function in 2 variables xy, u is a function in 2 variables xy, which is homogeneous. Now you know what is the meaning of homogeneous, which is homogeneous of degree n, then x del by u by del by x plus y del by u by del by y is equal to n into u. This is the Euler's theorem. Euler's theorem states that, you can also call it as Euler. Many students they call it, but I call it as Euler. Euler's theorem. Okay. If u is a function in xy which is homogeneous of degree n, then x del by u by del by x plus y del by u by del by y is n into u. This can be also written like this: x u suffix x plus y u suffix y is equal to n into u. And this is not difficult to prove, it is quite simple, because if u is homogeneous, I'll just explain you in short, nobody will ask you the proof, but you should know it. The remaining ones I won't prove it, but this one I'll show you. It's quite easy. If u is homogeneous, then what is the value? How do we write u? U is written as x raised to n into some function of y by x, correct? If u is homogeneous of degree n, then u can be written as x raised to n some function of y by x, correct? Yes or no?
Yes.
हो मैम.
That's why
Yes,
what will
ma'am.
be del by u by del by x? क्या होगा del by u by del by x? इस function का derivative. Is this function depending on x? ये function x पे dependent है क्या? हाँ है. दोनों भी functions है. So I have to use product rule to find the derivative. What's the product rule? X raised to n. What's the derivative of x raised to n? N raised
Into x raised to
minus
n
1.
minus 1
Very good. Phi of y by x plus x raised to n, and it is derivative of phi is phi dash of y by x into derivative of y by x with respect to x. Y by x का derivative with respect to x. Y constant, partial derivative घेतो. So y is constant.
Yes.
1 by x का derivative
minus y by x square.
minus 1 by x square. Is this okay? Is this expression clear to everyone? I'll repeat. परत एकदा सांगते. U is product of two functions. दोन functions चा product आहे. त्यामुळे partial derivative with respect to x घेताना y constant ट्रीट करायचं आहे आणि इथे दोन्ही फंक्शन x वर डिपेंड असल्यामुळे आपल्याला product rule अप्लाय करावा लागेल. What is product rule? पहिल्यांदा x raised to n चा derivative घ्यायचा, keep phi as it is. Take the derivative of x raised to n, keep phi as it is. That is n x raised to n minus 1 phi of y by x. Plus keep x raised to n as it is. X raised to n तसाच ठेवायचा आणि या फंक्शनचा डेरिव्हेटिव्ह घ्यायचा. What's the derivative of phi of y by x? Phi चा derivative phi dash of y by x multiplied by derivative of y by x, where y is constant. 1 by x derivative is minus 1 by x square. Okay, and now therefore what will be x del by u by del by x multiplied by x? So it will be n x raised to n. N minus 1 it was, I multiplied by x, त्यामुळे plus 1 होणार आणि I get n. So n x raised to n phi of y by x minus, just see this minus will come outside, I'll have y. Total how many n? X, n, this is minus 2 and I have multiplied one more x. परत एकदा बघा. x raised to n आहे, हे x square denominator मध्ये आहे आणि अजून एक x मी मल्टिप्लाय केला. So it is x raised to n minus 2 plus 1 into phi dash of y by x. That is nothing but n into this term is nothing but your u minus y x raised to n minus 1 phi dash of y by x. I hope this is clear to everyone. N minus 2 plus 1 is n minus 1. On the same lines, you will find what is delta u by delta y. For the last function 1 equation la differentiate kara with respect to y. Is that function depending on y? Yes. But now it is not product rule. There is only one function which depends on y. This is the function. This is constant. X is constant, so x raised to n will be constant. And you get phi dash of y by x into derivative of y by x. So what's the derivative of y by x? 1 by x is constant. Derivative of y with respect to y is 1. So this will become x raised to n minus 1 phi dash of y by x. And now look at the expression that I want. I want y delta u by delta y. So what it will become? Y x raised to n minus 1 phi dash of y by x. And therefore, this is, I'll call this as equation. This is equation 2. This is equation 3. And this is star equation. Then left hand side of star. What is the left hand side of star? It is 2 plus 3. Isn't it? Left hand side of star is 2 plus 3. So what is 2? 2 is nu minus y x raised to n minus 1 phi dash of y by x plus y x raised to n minus 1 phi dash of y by x. So plus y x raised to n minus 1 minus y x raised to n minus 1 will get cancelled. Therefore, your answer left will be n into u, which was your statement of Euler's theorem. Is this clear to everyone?
Yes, ma'am.
So the theory part is done in the theorem, and you have been given directly the output. What is the output? N into u. So henceforth, if your question asks you, this is the expression, find the value of x delta u by delta x plus y delta u by delta y. Then you have to first check whether the question is or whether the function is homogeneous. If the function is homogeneous, directly you write down the answer as n into u. Where what is n? N is the degree of that homogeneous function, and u is the given function. So you don't have to actually find the partial derivatives. Directly you write down the answer. That is the importance of Euler's theorem. You'll get the answer directly. Clear?
Hello, ma'am.
Yes, ma'am.
Yeah.
Miss, can you explain again that what was the difference between Euler's theorem and the previous? Because I was having some network issues, so I was unable to listen.
Okay. See.
Just tell in a gist.
Yeah. Till now, whatever partial derivatives we have found, actually we had to find delta u by delta x, delta u by delta y, multiply by x, multiply by y, and then get the answer. But now Euler's theorem is saying that if your function is homogeneous, then the partial derivative of this type, the expression of this type, x delta u by delta x plus y delta u by delta y is nothing but just n into u. And how did we get it? Since u is homogeneous, this is applicable only if the function is homogeneous. If u is homogeneous, then the given expression can be written as x raised to n into some function of y by x, or y raised to n into some function of x by y. You use any one of the form of homogeneous function, and you will get the expected statement of the theorem turning out to be n into u. Just that's what I have done. I first found that delta u by delta x by differentiating this function with respect to x using product rule, and then multiply it with x because I want that expression in this equation. Similarly, differentiate u with respect to y, where only one function is depending on y, so I will get the value of delta u by delta y as x raised to n minus 1 phi dash of y by x. And then multiply it with y, you will get y x raised to n minus 1 phi dash of y by x. So then what is the expected expression? It is equation number 2 plus equation number 3. When you add it, you see that minus y x raised to n minus 1 phi dash and plus x raised to n minus 1 phi dash cancels, and you get the expression as n into u, which is the statement of Euler's theorem. So actually it was being given by Euler, that's why it is called Euler's theorem. And that was good, it is important because you don't have to actually find the derivatives. The theorem gives you that directly the value of that expression is n into u. Okay?
Yes, ma'am.
Okay. So that is for first order. Similarly, there is second order also. That also we will write down, and then we'll solve the examples on it. So take down these. You have written the statement, everyone?
Yes, ma'am.
Yes, ma'am.
If you want, you can write down the proof, or else there is no need to write the proof. Again, you will get this one of the proof you will get in BS Grewal. That's the reference book for engineering mathematics. Once you come to college, you can take it, or I think so you'll get the soft copy also. BS Grewal, Dr. BS Grewal. This is a long time engineering book for mathematics. In that only the proof is not there of the theorem, but this expression is there, and one or two examples are solved. So you can go through that, and obviously the text that I have given you PDF, there are n number of examples of homogeneous function as well as of Euler's theorem. This is called as first order Euler theorem. Because why it is called first order? Can you tell me? Why it is called first order? Can you tell me?
Because of the derivative degree.
Yes, yes, the derivative are of first order, and that's why it is called first order Euler's theorem. Is it okay?
Yes.
So, yeah. So that's the first order. You write down the second order also. Let me tell you the second order, which will be obtained with the help of first order. This is an expression of first order Euler theorem. The second order is being obtained with the help of this. I'll tell you the statement. You can take it up as your homework and try to solve, see whether you get the answer or not. And you can get if you want. X square uxx means second order derivative plus 2xy uxy plus y square uyy is nothing but n into n minus 1 u. Just see. What is the expression? It is an expression of order 2. Each derivative is of order 2. How many times I am differentiating? 2 times. X means 2 times differentiable with respect to x. Xy means differentiable with respect to y first, then x first. Okay? That is also of order 2. And here also the order of derivative is 2 because we are differentiating with respect to y twice. If you had to find this derivatives, then how much time would it require? First ux, then uxx, then uy, then uyy, and uy again differentiate with respect to x. So at least it will take some time for finding the derivatives. But what Euler's theorem is giving you, is giving you the answer within one word or one line, that is n into n minus 1. It is so easy and it is so useful to get the answer directly. If an expression is of this type, and you come across many differential equations which are actual, the data which is given to you, you convert it to a differential equation which will be of this type, and the solution can be obtained without doing actual partial differentiation, writing the answer. Only restriction that the function should be homogeneous. If the function is homogeneous, obviously it will be of the polynomial form, and we know that all polynomials are continuous. So if they are continuous, their partial derivatives will be continuous, and what will happen? What will happen if the function is continuous and the partial derivatives are also continuous? Then what can you say about the mixed partial derivative? They will be equal. So this term which you are getting now, uxy. Once when you differentiate this function with respect to x, you will get xy uxy, and when you differentiate with respect to y, you will get xy uyx. But they will be same, and that's why you will add it and you will get them to be equal. Okay, now let me just give you the hint how actually they are going to become equal. Just see, this is an expression of order 1. Yes or no?
Yes, ma'am.
From this, I want to go to second order differential. From this only, I will try to go to second order differential. So how are we going to do that? Differentiate this with respect to x again. Differentiate this with respect to x again. So here you will use product rule. Y will be constant, and you will get deba square u by deba x deba y. And here you will get n into deba u by deba x. Is it okay? I am telling it short. There is no need to prove this, but I am telling you how to think and how to get. तो मुझे सेकंड ऑर्डर का डेरिवेटिव मिल गया डेबा स्क्वायर u by डेबा x स्क्वायर x मिल गया, यहाँ पे xy मिल गया, लेकिन मुझे क्या चाहिए x स्क्वायर. So that expression will multiply by x. So you will get x square डेबा uxx plus xy deba square u by deba x deba y, and here you will get n into x deba u by deba x. Same way, you find out, differentiate this equation with respect to y, multiply by y, and then add those two terms, you will get this answer. N into n minus 1 u. Is this okay?
Yes, ma'am. Yes, ma'am.
Fine? Okay, so you can try that. Those who are feeling that it is quite interesting, you can find it, try to prove it, and you will get the satisfaction once you know Once you are getting the answer, you will get that satisfaction that you have understood the concepts. Okay, fine. So now we are going to use them. We are going to apply them to solve the questions. We'll be given an expression which we have to find whether it is homogeneous. We have seen how do we find whether it is homogeneous or not. First हम लोग उसकी degree find करेंगे. Once I know the degree, if it is first order differential equation asked, answer will be n into u. If second order differential is asked, it will be n into n minus 1 u. So you write down this first of all. If u is homogeneous function of degree n, then second order Euler's theorem, second order differential by Euler's theorem, second order differential by Euler's theorem is x square uxx plus 2xy uxy plus 2xy uxy plus y square uyy is equal to n into n minus 1 u. N into n minus 1 u. Okay? Clear? Now we'll go to solve the questions. We'll go to solve the question. I'll start with a simple one, the ones which we have already done, the homogeneous function, and then we'll go to the complex one. Rather than complex, it is only lengthy, not difficult. This part is the easiest topic in partial differentiation. So take down, if u is equal to x cube y cube z cube divided by x cube plus y cube plus z cube, x cube plus y cube plus z cube, then find the value of x del by u by del by x plus y del by u by del by y plus z del by u by del by z. I hope I have not given you the formula for 3 variables, but I hope you know that this will be the formula for 3 variables. Or should I give you in note? Should I give you that note? If there are more than 2 variables, then what will be the formula?
Yes, ma'am.
Okay. So before writing this question, you please make a note. If u is equal to function of x, y, w, v dot. If u is f of x, y, w, v dot, then is homogeneous function of degree n, then x ux plus y uy plus w uw plus v uv plus dot is nothing but n into u. Okay. If there are 3 variables, what will be the value of, what will be the expression of second order? What will be the expression of second order? X square uxx, y square uyy, and z square uzz plus 2xy uxy
X Y plus 2YZ plus 2ZX.
All possible combinations, okay, is equal to n into n minus 1 u. Final answer will be same, but the expression on left hand side will change. Clear?
Yes, ma'am.
Yeah, yes, ma'am.
Yeah, so you have to find the value of this expression now. The question is, if u is this, then find the value of x del by u by del by x plus y del by u by del by y plus z del by u by del by z. The answer is quite simple. We have already done what is the degree of this homogeneous function. So while writing it, you will have to be, for a theory question, how you are going to write, that I'll explain you. But in your MCQ, directly you can write down the answer. So solution is u is equal to x raised to 9 upon x raised to 3 into some function of y by x comma z by x. Even if you don't show what is the function, it's okay. So that is equal to x raised to 6 into some function of y by x comma z by x, and hence u is homogeneous of degree 6, and therefore your answer is n into u, that is 6 into u. If you want, we can write down that expression what is u. So answer will be 6 into x cube y cube z cube upon x cube plus y cube plus z cube. Clear? Everyone? Yes?
Yes, ma'am.
Okay. Now we'll take another example. If u is equal to x square plus y square, if u is equal to x square plus y square upon x minus y, then prove that x to x plus y uy minus u is equal to 0. X ux plus y uy minus u is equal to 0. Can you see it is so clear?
Yes, ma'am.
Very simple.
Yes.
Yeah. So your solution will be, yeah, u is x square upon x into some function of y by x, that is x raised to 1 into some function of y by x. Therefore u is homogeneous of degree, what's the degree? 1, and therefore x ux plus y uy is equal to 1 into u, and therefore x ux plus y uy minus u will be 0. As simple as that. Okay?
Yes, ma'am.
Yes, ma'am.
Now let me give you one difficult question. Rather than difficult, let me come. A bit of logic we'll have to use, and we just imagine if you didn't have Euler's theorem, then what you have to do? You have to actually find the derivatives, multiply by x, multiply by y, and get the answer, which would have become a bit lengthy. And now because of Euler's theorem, the answer you are getting is within one step. Let me give you a question. U is equal to cos of x square plus y square upon xy plus x cube plus y cube upon x square minus y square. This is our expression. This is rather more, let me make it more simple first. Wait, I won't write it. 2x square y. Suppose this is the expression. Yeah. I'll make it simple and then we'll go to that complex, bit complex question. Now what is u? Is this homogeneous directly?
Yes, ma'am.
0.
Yes, ma'am.
Both of
Yes,
them,
ma'am.
u is actually b plus w. Can you see that? What is b?
Yes.
b is of degree 0 because it is x raised to 0. This is of degree 2 as well as this is of degree 2. Na?
Yes, ma'am.
Yes,
So it is cos of x square, I'll write it in this particular case, y by x the whole square upon x square into y by x. So this x square cancels, and that's why I can write x raised to 0 here. So this is homogeneous of degree 0. W, what about W? W is, you can take x cube common, it is 1 plus y by x the whole cube divided by, I'll take x cube common, it is 2y by x. So that also gets cancelled, and I can write it as x raised to 0 in some function of y by x. Therefore, this is also homogeneous of degree 0. Okay, and if you take u directly as a function, then u can be written as x raised to 0 into phi 1 of y by x plus phi 2 of y by x, because both of them are of same degree, and that's why it is x raised to 0 into new function of y by x. Sum of two function is again function, and that's why u is again homogeneous of degree 0. And therefore, the value of the expression x ux plus y uy will be 0 into u, and that is 0. Clear?
Yes, ma'am.
Everyone?
Yes,
Yes,
ma'am.
Okay, okay. Now you try to solve the question which I had given you. Cos of x square plus y square upon xy, and denominator is x minus y.
Ma'am,
Yeah,
please explain last case.
yeah, I'll explain. See here, when I take x raised to 0 common from the first term, this is a function of y by x which is not same as the function here. इथे काय होते cos of y by x. Here it is cos of some function of y by x, so I have named it as phi 1 of y by x. Okay, and here when I take the previous question, it was 2x square y. So x cube and x square y degree was 3. Both the places I took x cube common. So this expression is a function of y by x, which is not same as this. Is it same as this? There is cos outside. So it is phi 2 of y by x. Both of them are functions of y by x, but they are different. But total addition is a function of y by x. Yes or no?
Yes.
And what is the common term? X to the power 0. So u can be also said as homogeneous function of degree 0 because both the expression had same degrees. But if both expressions have different degrees, directly I cannot say u is homogeneous. Who will be homogeneous? The first individual function b will be homogeneous of some degree and w will be homogeneous of some fixed degree. And then we'll see how do I get the answer of that expression which is required. X ux plus y uy. Is that clear? Everyone? Okay, so let us do this example now. Okay, I'll rub off this. समझते हैं ना सगळ्यांना?
Yes, ma'am.
Oh, ma'am.
Actually, B I should have not rubbed off. So B was same. B is same. I'll write it as x raised to 0 cos of 1 plus y by x square upon y by x. If I take x square common, so B is homogeneous of degree 0. So if B is homogeneous, what I will get x dx plus y dy is equal to 0 into B. Correct? Who is homogeneous? B is homogeneous of degree 0. So Euler's theorem applied for B will be x dx plus y dy is equal to 0. Is equal to 0. If I do the same thing with W, W is numerator degree is 3, denominator degree is 1. So what will be the total degree? 2. हे समझते हैं ना? आता directly लिया. 2, 3 minus 1, that is 2 into some function of y by x. So W is homogeneous of degree 2, and therefore xwx plus ywy is equal to 2 into W. So this is one equation, this is second equation. Because they are individually homogeneous of different degrees. So I cannot combine them directly. But what I can combine? What can I write together? U is equal to V plus W. So what will be Ux? U चा derivative with respect to x म्हणजे काय? V चा derivative with respect to x आणि W चा derivative with respect to x ना?
Yes, ma'am.
Yes, yes,
This
ma'am.
will be Vx plus Wx. And therefore x ux will be x dx plus x wx. On same line, what will be y uy? Y dy plus y wy. And therefore this is say equation 3, this is say equation 4. Therefore adding 2, 3 and 4, what you will get? X ux plus y uy, which was the actual question asked, will become equal to, how I add? I will add like this. V term together, W term together. So x dx plus y dy plus x wx plus y wy, because I know what the answer of this. So what it is? 0 into v plus 2 into w. Your final answer will be 2 into, what's the function w? 2 into x cube plus y cube upon x minus 1. Is this okay? Simple? Okay. So that is the you can say beauty of Euler theorem, that without actually finding the partial derivative, we can directly write down the answer of that partial differential using Euler theorem, because it gives the answer directly. And they may also ask you what's the value at say 1, 2. Such type of questions can be asked. What is the value of the expression x is x plus y u r at 1, 2? What's the meaning of at 1, 2?
X value 1
X
and
equals to 1, y equals
Very
to
good.
2.
Put x is equal to 1 and y is equal to 2, and you get the answer. Okay, so the partial derivative, that expression becomes this, means it will be the point at which the tangent is say having a particular slope. So 1, 2 is the point which will give you the slope of the tangent to the plane, because now we are going in 3 dimensions. So you are going to have a surface. That surface will be intersected by the plane. When I'm taking the derivative of z with respect to x, means I'm talking about x, z o x plane. Suppose z is a function of xy. That's what I told you to go through the geometrical interpretation of partial derivative. When I'm differentiating z with respect to x, means the surface will be given. It's a 3-dimension of surface, because z will be given as xy function that will be intersecting the 3-coordinate system. When it is the derivative of z with respect to x, means the plane ZOX itself will intersect that, or will have a plane parallel to ZOX which will intersect the curve. And when you intersect, you will get a single, what you can say, curved line. That curve will be having a tangent at particular point, that is called as your partial derivative of z with respect to x. The way we had it in 2 variables. What was the thing? Y is equal to f of x was your curve, and dy by dx means was nothing but it was slope of the tangent to the curve. Okay, here it will be tangent to the curve intersecting, that surface has been intersecting with the plane, and then corresponding tangent line will get, and you get the slope of that tangent line. And if it is z with respect to y, then a plane parallel to ZOY will intersect the surface, and then that intersection of the surface will have a tangent line. Slope of that tangent line will be your partial derivative of z with respect to y. Okay, all these things you'll get in B.V. Ramana, Grewal book, and so on. Okay, but right now we are looking at the applications of partial derivative. Is this clear to everyone? So you please go through the examples that I have shared you in theory of partial derivative. Maybe on Monday I will give you the MCQs for